Hi. Okay, so I'm going to show you how to do that problem. Okay, so we have a rectangle here. And let's pretend that this side is 3 and 1/10, and this longer side is 7 and 1/2. There's probably a unit to go along with it, like inches or maybe yards. So our first step is to figure out how to find the area. Well, area is found by taking the base times the height, or vice versa. So we need to take 7 and 1/2 times 3 and 1/10. So in order to do this, the simplest way is to first convert these mixed fractions into improper fractions. And we do this in a certain, oops, hold on, I did something weird. Fractions. Okay, and we do this in a certain order. So for instance, 7 and 1/2 and 3 and 1/10, 7 and 1/2 would be converted by taking the denominator times the whole number. So 2 times 7, and then we add the 1. I put these in parentheses, the 2 and the 7, because I want to make sure I do those together instead of writing out 2 times 7 plus 1. I might accidentally do 7 plus 1 times 2, which would not be 15, it would be 16. So I like to think of PEMDAS, which is the order of operations which we do things in math. So parentheses, exponents, multiplication, division, addition, subtraction. So I need to first do what's in the parentheses. So, oh, hold on, I'm struggling today. Okay, so we have to bring our denominator over and then we can solve. 2 times 7 is 14, plus 1 more equals 15 over 2. So there's my improper fraction from 7 and 1/2. Okay, now we need to convert 3 and 1/10. So 3 and 1/10, so we take 3 times 10, or 10 times 3, same difference, and add the 1. Okay, now bring your denominator over, that does not change. Okay, now we can solve. 10 times 3 equals 30, plus 1 more equals 31 over 10. So just keep scooting over that denominator because we're not changing that. We have 31 over 10 and 15 over 2. Okay, so now that we have converted, now we can rewrite this equation. So we have 15 over 2 times 31 over 10. Okay, so the second step, we need to see if we can simplify. And sometimes this is tricky. So it might be easier to look at it like this. 15 times 31 over 2 times 10. Okay, this is the same thing as over here. I just put them together. So we could simplify maybe a little easier. Otherwise, you can use this way as well. Whatever works best for you. So in order to simplify, just like we were going to simplify maybe 5/15, I need to find what both the numerator and denominator have in common, such as factors. So I know that 5 goes into 15 3 times. So if I was to divide each side by 5, I could get 1 over 3 to equal 1/3. So same idea, except now we have options. So I have 15 times 31 and 2 and 10. So do you see a numerator and denominator that have something in common? Well, if I was to look at this, I know that 31 is a prime number. Only 1 and 31 can be times together to create 31. So that is out. I see that 15 and 10 both share a factor. For instance, 1 and 10, 1 times 10 equals 10, 2 times 5 equals 10, and that's about it. Kind of like to make this little rainbow of factors to help me write them out. So for 15, I have 1 and 15. 2 times, it would have to be 7.5, so that doesn't work. So 1, 2, 3, 3 times 5. Oh, they share a factor. These numbers can both be divided by 5. Okay, so let's just do that. So 15, whatever I do to the bottom, I have to do to the top. Okay, so now let's rewrite this. This is now equal to 15 divided by 5 is 3 times 31, and 2 times 10, 10 divided by 5 is 2. So as long as you do the same, as long as you divide or simplify your numerator and denominator by the same number, this helps us because it's a lot harder to multiply 15 times 31 than it is to multiply 3 times 31. So we can simplify in that way. Now, we need to solve. We need to multiply. That is our third step. So I'm actually going to rewrite this up. Oops, I'm going to rewrite this up here so we don't get so messy. 3. I can keep it in this state. Otherwise, I can rewrite this as 3 over 2 times 31 over 2. Either way. Okay, so in addition, we had to find the LCD, or least common denominator. It just happens to be that these two fractions have the same denominator now that we simplified it. They don't need to have the same denominator. All we have to do now is multiply straight across. So 3 times 31 is 93, and 2 times 2 is 4. Okay, so once you have this done, once you have multiplied them together, we can now convert back to a mixed fraction. All right, so we needed to do the reverse of what we did earlier in step number 1. So we take 93 over 4, and we need to see how many times 4 goes into 93. And you can do this by long division. So maybe you know how to get there a quick way. We could take, maybe I know that 4 goes into 93 20 times, and that would equal 80. Let's see what's left over. I have 13 left over. Ooh, 4. Oh, I know that 4 times 3 equals 12, and I have a remainder of 1. Okay, so in order to make a mixed fraction, we need to figure out our whole number. So how many entire or whole times did 4 go into 93? Well, I see that it went into 93 23 times. So, sorry, I'm getting kind of small over here. So 23 would be my whole number, and my numerator actually would be my remainder. So this is my remainder, and my denominator would be 4. So I could even double check this answer by doing what we did in step number 1. I could say, okay, 4 times 23 plus 1 more. And would that equal 93 over 4? We can check that too if we want to make sure we have the right answer. So hopefully this helps. I've got to go do a class. Please let me know if you have any questions. So it should be 23 1/4, and don't forget the unit that is in the question. Okay, thank you. Bye.